For more interesting videos, please like and share my videos, but do not forget to subscribe my channel and click the bell icon, and you will get all latest updates of my channel.
The seismometer we have on Mars is fantastic. It's operating as well as we could have dreamed. It's exceeding expectations. The goal of InSight is to understand the structure of the planet of Mars. And the primary way that we're going to do that with InSight is by measuring Marsquakes. ETH Zurich is leading the international team that is checking all of the data as it arrives every day and trying to detect and pass on the information that Marsquakes have actually occurred to the science team. We're down here in the simulator room of the Swiss Seismological Service, and we're here today to show the first example of replaying the first events that we've recorded from our seismometer on Mars.
So let's start with what we know, which is an earthquake. An earthquake from Switzerland takes 30 seconds and has very clear onsets, as we'll see.
So this Swissquake, we'll start with the P wave that you feel there, and then in a few seconds we'll hear the S wave arrival, slightly bigger. So that's the classic type of wave arrivals that we were hoping to see on InSight.
Next thing is one step more exotic, which is the moon. So we load a moonquake into our system and see how that feels.
This is the SP recording it, so there's no...
Yeah, is there an error banded on that?
Yes. Slowly getting bigger.
The signal is very different. We have a much smaller attenuation of the seismic waves, but at the same time we have a very strong scattering, which means that the shaking will go on for tens of minutes or maybe up to an hour.
Next thing we'll load into the system are the Marsquakes, which were discovered by the Marsquake service recently. We want to know how they feel on the scale between the Earth on one side and the Moon on the other side.
On Mars, we so far have seen two families of quakes, and so there's a higher frequency one, and this one that we experienced now was more the low frequency version. We think this is probably pretty far away. The motions that we have here are amplified by a huge factor so that we can even see them, because on Mars the amplitudes are extremely low.
Mars isn't as simple as we might have hoped. The ground motion is not like we see on Earth. It's sort of a halfway house between Earth and the Moon. We're really trying to put the various events in place. It's a big jigsaw puzzle at this stage, and we have a long way to go before we understand it, but it's extremely exciting at this stage.